Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on Advanced Fortran Programming. Now, in this video, I'll explain you guys how to do a where operation or a where construct that is available in Fortran. I'll explain you guys how to get the date and time from the system using a subroutine in the system, and then how to generate random numbers. This random number generation will be very simple. Okay, I've already written a program over here. It's quite little long, so I'll walk you guys through. Okay, I define two variables here, two integers here, r and c, for defining matrices p underscore n, a logical matrix p underscore n, and two real matrices ran mat 1, ran mat 2. Okay, and then I defined an integer, and I defined a values array whose values array which is like 8 units long, just 8 values, and then there is this integer case that's lying separately, and then I have an integer dimension, an integer array called a seed, which is allocatable. So I set the dimension to be unspecified here. I am not specifying the dimension here. We'll come to know how this works. Okay, now first let's go to the date and time operation. See, there's an inbuilt subroutine inside Fortran called as date underscore time. What it does is that it sends it does some internal calculations or measuring stuff. I don't know how exactly that it does, but it returns values. It returns an 8 valued array as the answer, as a subroutine answer. Okay, now this values on the left hand side is actually the system it's actually the subroutine value, whereas this is the value that gets outputted. It comes out. Okay, and now I just copied this from this comment statements from GCC GNU Fortran's online documentation. Okay, it's like this over here. I'll explain you guys what's happened here. Values is an intent out variable, and then the first value here will be the year, the second will denote the month, the third will denote the date in the month, then the fourth will denote the time difference from this current time zone that I'm working right now, or you're working right now, with the UTC time, or the universal time. UTC time, or the Greenwich Meridian time, whatever you call it, the time exactly at the 0 degrees longitude. Okay, and the time difference between that time zone and your time zone in minutes. Then it prints the hour of the day, then prints the minute of the hour, and then prints the second of the minute, and then it prints the milliseconds of the second whenever it's done. Okay, now what I'm doing is that with this the date and time is over. Okay, now I'll work on with random functions, random numbers. See, to generate random numbers, all you need is this subroutine call over here. That's it. This random underscore number, inside it takes some values, either a matrix or a number. It doesn't matter. It will generate the random number. This subroutine will generate a random number and stores it inside the matrix, and that's it. Nothing. That's it. But the problem is, I won't exactly say it's a problem, but what happens is that when you define something like this, and when you compile this program again and again and again, on a repeated basis, what happens is that you'll just get the same random number again and again and again. Same set of random numbers again and again and again. So to make the random numbers a little different, what I'm doing is that I'm just implementing a small set of routines, which I kind of browsed through online. Now to give courtesy to the person who did this. Okay, I was searching through some internet and I found this blog, I found this question and answer session in linuxquestions.org, and there's somebody asked, named CL. Okay, he asked a question like, how do I use random numbers and random seed such that the random numbers are different every time. Okay, and this person with this um, login name, I suppose, Suicide ALG Grawl, he wrote a small code here. Initially I didn't understand what's going on, but I have to implement this, test it with a few stuff, and got it. So this code, I kind of implemented this code over here. Thanks guys. Thank you. Thank you sir for your code. It kind of helped. So this way I thought of not acknowledging the person. Otherwise, if I just blindly copy this input, this will be like, this will not be good, right? So I thought I'll acknowledge this person. Okay, coming back. Okay, what it does, what that code actually does is that it calls this random underscore seed subroutine, okay, and assigns the value size to the value k. Now what does is that it generates a random series for seeding some for seeding some value to generate a random number. See, random number is generated like a sequence in Fortran. So what happens is that when this random number is called without having any value put into it, then it just generates the same sequence again and again and again, and prints the same sequence again and again. Now this stuff is used for altering the sequence, nothing more. Now this random seed gives a value for k, okay, and this value k will be the same all the time, because this k here before this line, we're not using the random seed again, random underscore seed subroutine, so this value will remain as is. So if you while compiling, if you get something like 14 or something for k, this value 14 will remain the same. And then what it does is, here I'm printing the value of k, and then what I'm doing is that I'm allocating the seed array on the top from values 1 to k, okay, from values 1 to k, and then I'm setting the value seed value all the values of seed to the values 8. Now what this does is that this 8 will actually be the millisecond that we'll get in this values. Okay, see, if you guys notice, the year will remain same for the year among the values, the year will remain constant for that particular year, the month for next particular 30 days or 28 days or some of, depending, the day will remain constant for that particular day. This UTC time differences will remain constant as long as you're in the same time zone or okay. It will change only when you change different time zones, or some kind of a catastrophic problem happens in the world and the time zones get altered. Just making a fun joke here. Anyway, this hour will change once in every hour. Minutes same as that, but seconds, yeah, they'll change, but no problem. But milliseconds, they'll just change instantly. Okay, at least for our understanding, at least for our conceptualization, milliseconds change every instant the program runs. So it will just generate kind of a random value between 0 and 999. Okay, so this value is being fed into this random seed over here, and what this does is that it takes, okay, that value 8 is being stored as all the values of seed here. Okay, and now I'm printing the seed just to give what's going on, and then I'm calling this random underscore seed, and using this put variable inside, what I'm doing is that I'm entering the value of this matrix seed into it. Thereby now it will generate an entirely different set of random number sequences. Okay, and with this being done, if I call this random underscore number and put mat 1, what it does is that it will generate a matrix of random numbers defined by this size, because this function, as I'm this function will this subroutine random underscore number will generate random numbers, and it takes inputs and an array, a 1D array, 2D array, 3D array, it doesn't matter. Even a scalar value, it doesn't matter. It just generate random numbers according to the size of the input, and it will just take care of it. That's it. Okay, and then I'm printing the values here. I'm printing the random number randmat1 here, and I'm printing the randmat2 here. I'm calling the random number function to get a new set of random numbers for randmat2. Okay, and that's it. Okay, with this our random number part is getting over, and now let's move to the var construct. Okay, now what does this var construct does is that it's an array operating construct wherein, okay, this function looks for a certain condition inside the array from top to bottom till from in all the indices. Now if that certain condition is achieved or is met somewhere, okay, then you can decide as to what can be done to other arrays or other. You can do something here based on whether this condition is met or not. This way, what you can do is that this var statement can be used as some kind of a masking statement, wherein if in a certain matrix you have certain values in certain set of values, and if certain values are like this, you can set another matrix whose value is like this. I'll explain you guys what I mean here. Okay, in this line what I'm doing is that if I find any matrix entry in randmat1 greater than 0.5, what I'm doing is that in the matrix randmat2, I am setting that particular value to be negative. Okay, if suppose in the third position, suppose in the second row and first column of randmat1 the value is less than 0.5, what it does is that in the corresponding location, the second row and the first column of randmat2, that value will be made negative. So if that value is actually already negative, it will be positive. If it's positive, it will be negative. But just a reminder, random number functions always give only a positive random numbers. If you want I think negative random numbers, you may have to work a little or find some other function that does it. As of now, these functions just give only positive random numbers. Okay, so what it does is that this number becomes a negative value over here, and this is not the only construct available for var. You can use an else var also, making it completely like a logical matrix or stuff. Okay, since I defined a logical matrix over here, I'm using that over here. Now what I've done is that after making this alteration over here, I'm making a condition. If you find some value in randmat2 to be greater than 0, okay, then set the matrix p underscore n in those indices to be true. Okay, else set the remaining, if in indices where this value is not met with, set those indices in p underscore n to be false. So what you'll have is that you'll just have a matrix that shows whether which indices are true and which indices are false, something like a masking function. Now this kind of job is essentially a masking. This kind of array operations, essentially array masking stuff. So you can use this for not only for masking, for doing other decisions also. That depends on the need. I am printing the matrices here using this print underscore mat r2 to print this real number matrix, and I'm printing this matrix print underscore mat l2 to print this logical matrix. And now I'm on the top, I'm printing the random matrix randmat1 using the same function print underscore mat r2. Okay, and then this value print underscore mat1 to print the values, which is a 1D matrix. Okay, this will be, and if you guys want to know how this is run, I've written 3 subroutines over here. These are essentially the same. What it does is that it does the subroutine. It's just exactly the same subroutine we saw in the previous tutorials to print the matrices. Okay, 2D matrices. What I've done is that I just changed the data type to in this mat r2 to be real. Okay, and then I set the formatting to be real over here, and here the mat and print underscore mat L2. This is logical. L stands for logical. See here, so I set this to be logical here, and I return a logical uh, you know a logical format over here, and that's it. And here it's just integer, so I just put integer, so we used just print underscore mat1 alone, with keeping it to be a default integer. So I set the data type for the matrix to be integer here, and I write item. Simple enough, nothing more, nothing less. Suppose if I let me write this as 6, it may not go all the way to 6 decimal six places and all. Okay, now that being said, let's execute this. I have written a small shell script to do the same. I am removing all the module, object and executable files here. I'm comparing the comparing the file, building the file to get an executable, running the executable. Now there's one advantage in Genie. Instead of going to the terminal right now and executing this bash script, and as long as you made this an executable, what you can do is simple. All you have to do is that press F5. Come here and press F5. Okay, that's a little embarrassing. It should come anyway. Okay, anyway, if this isn't working, let's execute from here. Yeah, it's working. Anyway, now what it does is that it just prints everything from the top, removes files and executables, case 12. Okay, and it puts C to be 132. There are 12 values of K. The value of K is 12, so there are 12 values of the C. If you can notice, 1 2 3 4 5 6 7 8 9 10 11 12. There are 12 values of C. They are all the same. Okay, and the date is printed as it is. And if you guys compare the conditions over here, okay, the year is 2015 and today's date is the date when I recorded this video. It's 2015, and it's May. The month is May, and it's 14th. I'm recording this on 14th May. Okay, and then I'm in India, so the time difference between UTC and my place is 5 hours and 30 minutes, so that's 330 minutes. And then when I record this video, it's 1 p.m. in the afternoon. When I run this, it's 1 p.m. in the afternoon, and post 10 minutes after 1 p.m. and it exactly ran at 48 seconds and 152 milliseconds. So this is how this terminology goes here as for the date and time subroutine is concerned. And then it prints the random matrix ranmat1 here. Okay, and as per our var function, what it does is that if in these locations if you see, the values are less than 0.5. so in these locations, okay, the random matrix initially is all positive, but in these locations, since these are less than 0, these gets converted into negative because of this var construct over here. And what happens is that now, since this is fixed, now using this var operation over here, var's construct over here, wherever the ranmat is greater than 0, this p underscore n matrix is set to be true, and wherever it is false, it is set to be false. Wherever it is less than 0, it is set to be false. Alright, and if you guys just have a look at this, these are the matrices like that. Now if I were to build this, and if I were to execute this again, for some reason my only this is working, and if you guys notice, this is essentially a different set of values, except for this part over here. The matrix is itself is entirely different. But if you guys remove the seed and all this job and run the same, I'm pretty sure it will be different. Okay, now I think that's too much information for this one tutorial. I'll stop here. uh, I'll in the next tutorial I'll explain you guys with some other interesting topic that will be of great importance. Thank you guys for watching, and I'll see you guys in the next tutorial. So bye and take care.